This unit is all about thermodynamics. Well, what is thermodynamics? Like many words that we've looked at this year, let's break it down. So we have the word thermo, and thermo refers to heat or temperature. Dynamic means something that's dynamic moves, so dynamic refers to movement. So thermodynamics is the study of the movement of heat or energy. We'll make it a little more broad. So really, thermodynamics is the study of the movement of heat or energy. And we'll define these terms a little bit more later on. When we talk about thermodynamics, there are 3 laws of thermodynamics. These are rules that we've observed in nature that always hold. It doesn't matter where in the universe you are, under what conditions, the laws of thermodynamics always hold. So the first law is that the energy, or the total amount of energy in the universe, is constant. And this is also known as the law of conservation of energy. And it says the exact same thing as the law of conservation of mass. And that is, energy cannot be created or destroyed. It can only be transferred or change forms. So when we talk about energy, for example, let's think about the energy we get in food. Well, where does that come from? It starts as solar energy, light from the sun. That light energy is converted into chemical energy in a plant. That food is eaten by some animal, maybe it's eaten by us, and we take that chemical energy and turn it into maybe mechanical energy if we use it to move, or sound energy if we use it to speak. During that entire process, no energy is created or destroyed, it just changed the form of that energy. So let's make a list of some of the common forms of energy that we'll see. So we have types of energy. So we have light energy, we have heat energy, we have kinetic energy, potential energy, electrical, chemical, and mechanical energy, the energy of movement. And there's a lot more. So these are some common ones, and energy can change forms. The second law of thermodynamics states that in any process, the entropy of the universe tends to increase. Well, what is entropy? Well, entropy is a measure of the disorder, and we can almost think of this as the messiness of the universe. We can also say that energy tends to spread out. An analogy of entropy is you have your room and you put a lot of energy into cleaning it up, and what happens after a long time? Well, your room gets really messy. Things tend to get disordered. You have to put a lot of energy back into your room in order to get it neat again. So in any type of process, the disorder, the messiness, tends to increase. You tend to get more particles and you tend to spread out any energy. The third law of thermodynamics is at absolute zero, entropy is zero. So once you hit absolute zero, there is no disorder. Everything is organized. And we can use these three laws of thermodynamics to solve many problems that we'll encounter in chemistry.